Welcome to Module 8, Evidence of a Beginning of the Universe from the Borde-Vilenkin-Guth Theorem. This is the 8th module in a 12-module series entitled God and Modern Physics. It is presented by Father Robert J. Spitzer of the Magis Center of Reason and Faith, and it is based on his recently released book, New Proofs for the Existence of God, Contributions of Contemporary Physics and Philosophy.
Welcome to the Magis Center of Reason and Faith series, God and Modern Physics. I'm Father Robert Spitzer, and we've been talking about the evidence for the existence of a creator, supernatural design, the evidence for God that comes from contemporary physics and astrophysics. In our last episode, we were speaking about the evidence from space-time geometry for a beginning. And remember, we were trying to establish, if the Big Bang weren't the beginning of the universe, if there was a pre-Big Bang period, and the pre-Big Bang period maybe was a universe embedded in a multiverse, or the pre-Big Bang period was a bouncing universe, or it was some kind of quantum gravitational universe that extended infinitely back into the past, well, then perhaps there wouldn't have to be a beginning of the universe. But as we have already seen from the law of entropy, it is highly likely that the universe did not exist infinitely back into the past, that it did have a beginning, that it couldn't have bounced for an infinite number of bounces. Indeed, if it could have bounced at all, and now we've seen from the evidence of space-time geometry that in fact it looks highly unlikely that the universe could have avoided a beginning, because the Borde and Vilenkin proof from 1993 shows that the universe very, 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 very likely will meet the 5 conditions necessary for a singularity, a beginning point of space-time from its inflationary condition. We've seen from the modeling that Guth has done that every mathematical model of the universe that physicists have tried to piece together that could be connected with our universe required a beginning. And then we saw the Borde-Vilenkin-Guth theorem, and in the Borde-Vilenkin-Guth theorem, the BVG theorem, we saw that the universe would have to have a boundary to its past time, because one cannot go arbitrarily back into the past without relative velocities going over the speed of light. Now, there's only one caveat of the BVG theorem, and that is that boundary to past time, it could either indicate a transition to a previous physics, to a universe or a universal condition with another kind of physics, or it could indicate a boundary to past time itself, an absolute boundary to past time, something really fundamental like a singularity prior to which there could be no physical event. Now, here's the thing with the BVG theorem. In our last episode, we saw it's applicable to just about anything. It's applicable to a multiverse, it's applicable to a bouncing universe, it's applicable to a quantum cosmological universe. The only condition that has to be met in order for the BVG theorem to predict a beginning is that the average Hubble expansion, the average rate of expansion of the universe, has to be greater than 0. But that seems to be the case for every single pre-Big Bang condition that could possibly be attached to our expanding universe. For example, we see that even if there was a quantum gravitational condition, eventually that previous quantum gravitational condition would have to have an average Hubble expansion greater than 0. It too would have to have a beginning. And a multiverse can only exist in an inflationary condition. An inflationary condition by definition is expanding. So every multiverse is going to have a beginning. And even bouncing universes are going to have a beginning, because what the BVG theorem says is only the average expansion. In other words, the average of the bounces, the expansions and contractions, only the average of the expansions and contractions has to be greater than 0. Well, if the universe begins with an expansion, then the average rate of expansion of the universe over all of the expansions and contractions always has to be greater than 0. So for virtually every conceivable pre-Big Bang universal condition that we can conceive of going back as far as you want, You're always going to have a boundary of past time. And eventually you're going to get a boundary which is absolute. A boundary which is a beginning of past time itself, which boundary constitutes a point at which the universe, or any multiverse in which it could be situated, came literally into existence. And that would be an absolute beginning. Now let's take a look at our diagram once again. Where have we come so far? If you put together the evidence from entropy, the ratio of CMB radiation to starlight, the Tolman limit that predicts an infinitely small radius with an infinitely small cycle, if indeed there were any bounces. If you put together the Penrose calculation against our low entropy universe and try to go backwards as it becomes more improbable, as you put together the Borda and Vilenkin 1993 proof, which has only one loophole, which is highly, highly, highly improbable for our universe, the mathematical modeling of Guth, and now the 2003 Borda, Vilenkin, and Guth theorem, which, by the way, right now have absolutely no exceptions that have been formulated for it. Indeed, the exceptions which have been formulated for it all do not seem to be physically realistic. There have been some physicists who've actually tried to propose a static universe, but a static universe isn't going to work because a static universe is metastable. It's going to have to go into an expanding universe at some point, and that metastable universe itself, by definition, has to have a beginning. And some physicists have actually postulated bouncing universes, but as we've already seen, all you have to have is an average Hubble expansion greater than 0. So if the universe begins with an expansion and then goes to a contraction, the average Hubble expansion is greater than 0, BVG theorem applies to it. So the only kind of bounce you can have is one that starts with a contraction, and trying to start with an expanded state and go to a contraction, then to expansion, is a very, very difficult thing to prove and to attach to our universe. Most of those things are physically unrealistic. And at one point, physicists actually tried to deconstruct time and make time's arrow go backwards in a previous state, but really, in fact, that doesn't work either. And in my book, New Proofs for the Existence of God, you can see a complete analysis of why the deconstruction of time is physically unrealistic, and most physicists recognize it to be so. So where do we stand when you put all of this evidence together? We stand at 6 different evidence points, 3 from the law of entropy and 3 from space-time geometry, that are all converging on a single conclusion, that the universe had a beginning, a point at which it came into existence. And those 6 data points converging on that single conclusion make it both highly corroborated, highly probable, and exceptions to it very, very difficult, indeed very, very improbable. In fact, if anybody can come up with a possible way of getting around it, it might be just a testimony to human ingenuity than it is to something which is realistically attachable to our universe. The state of the research right now seems to indicate that the universe had a beginning. And let's go back to the significance of a beginning for just a second. If the universe had a beginning, then the universe also has a point at which it came into existence. If it had a point at which it came into existence, then prior to that point, it's physically nothing. There's no physical reality. There's nothingness. And we all know that from nothing, only nothing can come. And if that is the case, then something, not the universe, something transcending the universe, something greater than the universe, would have had to have created that universe, thrown the universe with its space-time, its constants, its mass energy into existence at a single moment, a powerful cause indeed. In our upcoming episodes, as we shall see, we have a third source of evidence, as we can see from our diagram, called anthropic coincidences. And those anthropic coincidences, in turn, are going to be showing us that this transcendent and powerful cause is going to be very intelligent, or in the words of Fred Hoyle, who used to be an atheist and came around because of one of these anthropic coincidences to theism, he points out to a super calculating intellect, which really makes any idea of blind forces highly, highly improbable. But we shall talk about them in the next episode, because when all three evidence points are put together, we shall see the very high probability of a super calculating, super intellect, transcendent, powerful creator creating our universe so that intelligent life might emerge. Thank you.
To learn more about this series and the Magis Center of Reason and Faith, please visit www.magisreasonfaith.org. That is www.magisreasonfaith.org. You may purchase Father Spitzer's book on this subject, New Proofs for the Existence of God, Contributions of Contemporary Physics and Philosophy, on the website or through Amazon.com.